When mysterious objects like 3I Atlas streak through our solar system, how do scientists determine if they're natural space rocks or, something far more extraordinary? The process of distinguishing between cosmic debris and potential alien technology involves rigorous scientific methods, advanced telescopes, and careful analysis of physical properties. From spectral signatures to orbital mechanics, astronomers have developed sophisticated techniques to separate fact from fiction in the search for extraterrestrial intelligence. A rare visitor from deep space. What makes an object suspicious enough to warrant investigation for potential alien origins? When astronomers discovered 3I Atlas in July 2025, they immediately began analyzing its characteristics using established protocols for identifying unusual celestial visitors. The object's extreme velocity of 58 kilometers per second and hyperbolic trajectory initially raised questions about its nature, similar to how Oumuamua sparked scientific debate in 2017. Scientists look for specific markers that distinguish natural objects from potential artificial constructs, including surface composition, structural integrity, and behavioral patterns. Natural interstellar objects typically display predictable properties based on their formation in distant stellar systems, while hypothetical alien technology might exhibit anomalous characteristics that defy conventional physics. The key lies in systematic observation and measurement rather than speculation. Professional astronomers use multiple independent observation methods to verify their findings and eliminate human error or equipment malfunction. Every mysterious space object receives the same rigorous scientific scrutiny, ensuring that extraordinary claims require extraordinary evidence. This methodical approach has successfully identified thousands of natural objects while maintaining vigilance for genuinely anomalous discoveries. The scientific community remains open to finding evidence of alien technology while maintaining strict standards for verification and peer review. The breaking discovery. How do scientists separate genuine discoveries from false alarms when studying mysterious space objects? The confirmation process begins immediately after initial detection, involving multiple independent observations from different telescopes worldwide. When Atlas telescopes first spotted 3I Atlas, teams at observatories across Chile, Hawaii, and South Africa began collecting data to verify its properties and trajectory. Scientists analyze orbital mechanics first, determining whether an object follows natural gravitational physics or exhibits unexplained acceleration patterns that might suggest propulsion systems. Spectroscopic analysis reveals surface composition, helping distinguish between rocky, icy, or metallic materials that provide clues about natural versus artificial origins. The object's rotation rate, brightness variations, and thermal emissions undergo careful scrutiny to identify any anomalies inconsistent with natural formation processes. Professional astronomers coordinate through international networks, sharing data and cross-referencing observations to eliminate observational errors or equipment malfunctions. The International Astronomical Union maintains strict protocols for announcing discoveries, requiring multiple confirmations before official designation. Scientists also consider alternative explanations for unusual properties, exploring whether natural phenomena could account for seemingly anomalous characteristics. This systematic approach ensures that only genuinely unexplained objects receive serious consideration as potential evidence of alien technology, while protecting the scientific community from premature or inaccurate conclusions that could damage public trust in astronomical research. The discovery story. What specific techniques do astronomers use to analyze potentially artificial objects in space? The investigation process relies heavily on photometry, spectroscopy, and astrometry to build comprehensive profiles of mysterious visitors. David Jewett and Jane Liu, pioneers in studying distant solar system objects, established many protocols now used for interstellar object analysis. Scientists measure brightness variations over time, looking for rotation patterns that might indicate artificial symmetries or unusual structural properties inconsistent with natural formation. Spectral analysis reveals elemental composition by examining how objects absorb and reflect different wavelengths of light, providing chemical fingerprints that distinguish manufactured materials from natural rock, ice, or metal. Thermal imaging detects heat signatures that might indicate internal power sources, active machinery, or artificial temperature regulation systems. Radio telescopes scan for electromagnetic emissions that could signal communication systems, navigation equipment, or other technological signatures. High-resolution imaging attempts to resolve surface features, searching for geometric patterns, artificial structures, or manufacturing marks that would distinguish technology from natural geological processes. Scientists also monitor for trajectory changes that might indicate course corrections, propulsion systems, or intelligent navigation, rather than purely gravitational motion. The Very Large Array and other radio telescope networks continuously monitor for signals from objects of interest. Modern computational power allows rapid analysis of vast datasets, enabling scientists to process observations from multiple wavelengths simultaneously and identify subtle anomalies that might escape individual telescope observations. A stranger in our midst. So, how do natural objects behave differently from potential alien artifacts when observed through powerful telescopes? Well, natural interstellar objects typically show predictable characteristics, based on their formation environments and the effects of cosmic ray exposure during their really long journeys through space. Asteroid composition usually follows known patterns, rocky, metallic, or icy materials that are consistent with planetary formation processes around distant stars. Scientists expect natural objects to display signs of space weathering, like surface darkening from cosmic ray bombardment and micrometeorite impacts that build up over millions of years. Their rotation rates generally fall within ranges determined by gravitational interactions during ejection from their parent star systems, and these are typically measured in hours, not artificially precise periods. When it comes to comets, natural outgassing produces predictable chemical signatures as volatile materials sublimate while approaching the sun, creating those characteristic coma and tail formations. The structural integrity of these objects follows physical laws, how different materials respond to gravitational stresses, temperature swings, and rotational forces during interstellar travel. Scientists use computer models to predict how various natural materials would appear after extended exposure to cosmic radiation and extreme temperatures in interstellar space. On the other hand, artificial objects might show unusual geometric shapes, precise rotational periods, unexpected material compositions, or surface features that just don't line up with natural formation processes. The Spitzer Space Telescope and other infrared instruments can detect thermal anomalies, which might hint at internal power sources or artificial heating systems. And with advanced imaging techniques, researchers examine surface textures, searching for manufacturing marks, geometric patterns, or structural elements that would suggest intelligent design rather than natural geological or impact processes. The predecessors. What lessons did scientists learn from previous mysterious objects that shaped current investigation protocols? The 2017 discovery of Oumuamua really changed the game for astronomers, establishing comprehensive analysis frameworks that are still in use today. Robert Warwick at the University of Hawaii was the first to detect Oumuamua, which showed unusual acceleration patterns that initially puzzled scientists, until natural explanations involving outgassing were confirmed. The controversy over Oumuamua's elongated shape and slight acceleration taught researchers the importance of gathering multiple types of observational data before jumping to conclusions. Avi Loeb from Harvard University suggested considering artificial origins for Oumuamua, which sparked important discussions about scientific methodology and the burden of proof needed for extraordinary claims. Then there was 2I/Borisov, discovered in 2019 by amateur astronomer Gennady Borisov, which provided a more conventional example of an interstellar comet with clearly natural characteristics. These experiences established standard protocols for studying interstellar objects, like immediate spectroscopic analysis, trajectory monitoring, and international coordination for follow-up observations. Scientists learned to consider both natural and artificial explanations at the same time, while maintaining rigorous standards for evaluating evidence. The experiences with these objects also highlighted the need for rapid response capabilities, since interstellar visitors are only observable for limited time periods before they leave the solar system. Nowadays, modern protocols include automated alert systems that notify astronomers worldwide within just a few hours of discovery, enabling coordinated international observation campaigns to maximize data collection from these rare cosmic visitors. The cosmic journey. How do orbital mechanics help scientists distinguish between natural objects and potential alien spacecraft? Well, natural interstellar objects follow predictable trajectories determined by gravitational interactions with the sun and planets. while artificial objects might show unexplained course corrections or propulsion signatures. Gravitational physics gives us precise mathematical frameworks for calculating expected paths, allowing scientists to spot any deviations that could indicate active navigation systems. For example, the trajectory of 3I/Atlas follows a hyperbolic orbit with an eccentricity of 6.14, which is totally consistent with natural ejection from a distant star system millions of years ago. Scientists use sophisticated computer simulations to trace backward trajectories, trying to identify possible origin star systems and validate natural formation scenarios. Of course, unexpected acceleration or deceleration patterns might indicate propulsion systems, though natural phenomena like outgassing can also cause trajectory changes in comets and asteroids. JPL's navigation teams keep a close watch on object trajectories using radar and optical observations, measuring positions with extraordinary precision to catch even the subtlest motion anomalies. Artificial objects could show perfect geometric flight paths, precise timing and trajectory changes, or acceleration patterns that just don't fit with known natural forces like solar radiation pressure or gravitational slingshot effects. The Deep Space Network offers radar tracking capabilities that can pick up tiny changes in velocity or trajectory that optical telescopes might miss. Scientists also analyze how objects respond to solar radiation pressure, gravitational perturbations from planets, and other natural forces, just to make sure their motion follows purely physical laws, or to see if it hints at intelligent control systems managing their flight paths through the solar system. A scientific goldmine. What advanced technologies enable scientists to determine if mysterious objects are natural or artificial? Well, modern astronomical instruments provide, honestly, unprecedented capabilities for analyzing the physical properties and behavior of potential alien artifacts versus natural space debris. Spectroscopic analysis, using instruments like those on the James Webb Space Telescope, can identify specific chemical compositions, revealing whether objects contain materials consistent with natural formation or, unusual artificial alloys. High-resolution imaging from ground-based adaptive optic systems and space telescopes can resolve surface features as small as tens of meters, searching for geometric patterns, manufacturing marks, or structural elements that would indicate intelligent design. Radio astronomy facilities like the Very Large Array continuously monitor for electromagnetic emissions that might indicate communication systems, navigation equipment, or other technological signatures from mysterious objects. Infrared observations detect thermal signatures that could reveal internal power sources, artificial heating systems, or temperature regulation inconsistent with passive solar heating of natural materials. Advanced computer modeling allows scientists to simulate how various materials and structures would behave under different conditions, comparing observations with theoretical predictions for natural versus artificial objects. Gravitational wave detectors provide additional monitoring capabilities for massive objects that might employ, say, exotic propulsion systems. Machine learning algorithms process vast amounts of observational data, identifying subtle patterns and anomalies that might escape human analysis. And finally, international coordination through networks like the International Astronomical Union ensures that multiple independent teams analyze the same objects, reducing the risk of observational errors or biased interpretations that could lead to false conclusions about potential alien technology. Unanswered questions. What specific characteristics would definitively identify an object as alien technology rather than natural space debris? Scientists have established clear criteria for distinguishing artificial constructs from natural celestial objects, though, some borderline cases continue to challenge conventional analysis methods. Geometric precision in shape, surface features, or rotational periods would strongly suggest intelligent design, since natural processes rarely produce perfectly symmetrical or mathematically precise structures. Unusual material compositions containing pure metals, artificial alloys, or isotopic ratios inconsistent with stellar nucleosynthesis would indicate manufacturing rather than natural formation processes. Active electromagnetic emissions, especially coherent radio signals or structured data transmissions, would provide compelling evidence of technological origin and possibly intelligence. Propulsion signatures including unexplained acceleration, trajectory corrections, or energy emissions inconsistent with known natural forces would suggest artificial control systems. Surface features showing clear geometric patterns, construction joints, or manufacturing marks visible through high-resolution imaging would distinguish technology from natural geological processes. Internal structure revealed through radar or gravitational analysis might show artificial compartments, machinery, or organized systems, rather than homogeneous natural composition. Thermal anomalies indicating internal power sources, temperature regulation, or waste heat disposal would suggest active technological systems rather than passive solar heating. Response to external stimuli, such as changes in behavior when approached by spacecraft or exposed to radio signals, might indicate artificial intelligence or automated systems. The SETI Institute maintains protocols for evaluating potential techno-signatures, requiring multiple independent confirmations before announcing discoveries of artificial objects. Scientists continue refining detection methods and analysis techniques to ensure they can recognize genuine alien technology while, avoiding false positives from natural phenomena. The alien question. How do scientists balance open-minded investigation with rigorous skepticism when evaluating potential alien artifacts? The scientific method requires maintaining both receptivity to extraordinary discoveries and strict evidential standards that prevent premature conclusions about alien technology. Avi Loeb, chair of Harvard's astronomy department, advocates for seriously considering artificial origins when natural explanations prove inadequate, while emphasizing the need for extraordinary evidence to support extraordinary claims. Carl Sagan's famous principle that extraordinary claims require extraordinary evidence guides most astronomical investigations, ensuring that potential alien discoveries undergo the most rigorous peer review and verification processes. Scientists recognize that discovering genuine alien technology would represent one of humanity's most significant achievements, requiring absolute certainty to avoid false announcements that could damage scientific credibility. The SETI Institute has developed comprehensive protocols for evaluating potential techno-signatures, including multiple independent verification requirements and international coordination before making public announcements. Natural explanations must be thoroughly explored and eliminated before considering artificial origins, as the history of astronomy shows that apparently anomalous objects often have conventional explanations discovered through continued observation. Peer review processes ensure that multiple independent scientists analyze the same data and observations, reducing the risk of individual bias or analytical errors that might lead to incorrect conclusions. The scientific community maintains healthy skepticism while remaining genuinely open to discovering evidence of alien technology, balancing the need for rigorous investigation with the recognition that such discoveries would profoundly impact human understanding of our place in the universe and the prevalence of intelligent life throughout the galaxy. Dawn of a new era. What does the future hold for detecting and analyzing potentially artificial objects in our solar system? Technological advances in astronomy continue revolutionizing our ability to identify, track, and study mysterious visitors that might represent alien technology rather than natural space debris. Next-generation telescopes like the Vera Rubin Observatory will survey the entire visible sky nightly, dramatically increasing discovery rates for interstellar objects and providing rapid alerts for international follow-up observations. Advanced artificial intelligence systems will analyze observational data in real time, identifying subtle anomalies and patterns that might escape human attention, while flagging objects requiring immediate investigation. Space-based observation platforms will provide continuous monitoring capabilities without atmospheric interference, enabling detailed spectroscopic and thermal analysis of potentially artificial objects throughout their solar system passages. Improved international coordination through organizations like the International Astronomical Union ensures rapid information sharing and coordinated observation campaigns that maximize data collection from rare interstellar visitors. Radar astronomy facilities continue expanding their capabilities for detailed trajectory tracking and surface mapping, providing unprecedented precision in detecting artificial structures or unexpected motion patterns. Future space missions might include dedicated interceptor spacecraft designed to rendezvous with mysterious objects for close-range analysis, collecting samples and detailed measurements impossible from ground-based observations. The Breakthrough Listen project and similar initiatives continue expanding radio monitoring capabilities, searching for electromagnetic signatures that might indicate technological origins. Enhanced computer modeling and simulation capabilities will enable more sophisticated analysis of observational data, comparing observations with theoretical predictions for both natural and artificial objects to distinguish between conventional explanations and genuinely anomalous discoveries requiring extraordinary investigation. The search for alien technology requires balancing scientific rigor with open-minded investigation, ensuring we don't miss genuine discoveries while avoiding false alarms. As our detection capabilities advance, astronomers remain vigilant for objects that might represent humanity's first contact with extraterrestrial intelligence. Every mysterious visitor gets the same careful analysis, protecting both scientific credibility and our readiness for extraordinary discoveries. Keep exploring the cosmos with Simply Science. Like, share and subscribe for more fascinating insights into our universe's greatest mysteries.